So this question says, suppose the second derivative of f of x is given by this function here. Determine the intervals of concavity of f of x. So to determine the intervals of concavity, all we're going to do is set the second derivative equal to 0, and then we're going to use a number line test. Where positive results represent concave up, and a negative result represents concave down. So let's do that. So we have our second derivative. The question's already told us that it is 40 x to the 8th power times x plus 5 to the 7th power times x squared plus 16. So I can set that equal to 0. I'm looking at this as the product of three terms: this first term, this second term, and this third term. So there's no need to simplify this at all. I just set each of these terms equal to 0. So I set 40x to the 8th equals 0, x plus 5 to the 7th power equal to 0, and x squared plus 16 equal to 0. My reason for doing that is I'm looking for x values that make this statement true. And the only way this statement is true is if this is equal to 0, because then 0 times everything after it would still make the answer 0. Or if this term is equal to 0, because it wouldn't matter what came before or after, because you're multiplying by 0, so it would also make the entire statement truly equal to 0. Or the last term is equal to 0 for the same reasons as before, right? So that's all we're setting up in the second line. It's just what x values do we get by setting each of those individual parts equal to 0. So for this first part here, I can divide by 40 on both sides and get x to the 8th equals 0. I can 8th root both sides, and I'm just going to get x equals 0. So there's one of my critical points there. For here, I can take a 7th root of both sides and get x plus 5 equals 0. Subtract 5 from both sides, and I get x equals negative 5. So that's my second critical point there. And for this question, I'd have x squared equals negative 16. So there really wasn't a need to put that in parentheses. But I can't ever have negative 16, right? If I took the square root of this, I'd have x equals plus or minus 4i. And we're not dealing with imaginary numbers in this class, or at least at this stage. So this is not going to matter for me, but these will, negative 5 and 0. So now the next thing to do is to create my number line and do a number line test, where I have 0 and negative 5. I'm then going to choose some points in between these, or to the left and right of these points, I should say, to test. So I'm going to try negative 6 here. I'm going to try negative 1 here. I'm going to try a positive 1 there. So what's happening when x equals 6? So when x equals negative 6, f double prime of x is positive or negative. That's really all I care about. So when I plug negative 6 into my f double prime, let's just write it out here. Again, 40 x to the 8th, x plus 5 to the 7th, and x squared plus 16. So if I were to plug a negative 6 in for x, I'd have a negative 6 there, but negative 6 to the 8th power, or anything negative to an even power, is still going to be positive. So this whole thing is positive. If I put a negative 6 in here, negative 6 plus 5 is positive 1. I'm sorry, negative 6 plus 5 is negative 1. And then negative 1 to the 7th power, an odd power, is actually going to be negative. Because any negative number to an odd exponent will remain negative. And then in here, if I put a negative 1 in there, negative 1 to the 2nd power is positive, plus 16, it stays positive, so this is a positive. So I have a positive time negative time positive, which ends up giving me a result of a negative. Okay, so positive times negative is negative, and then negative times positive stays negative. So this is going to be a negative, which means we're concave down here. So what is this region? Well, this is everything between negative infinity to negative 5. We expect all of that to be concave down. Now let's try this negative 1. Let's try this number here. So let me just erase this. So we're going to plug negative 1 into our second derivative. So just writing this out again. So if I put a negative 1 into my x here, again, it's raised to a even exponent, so it makes it positive. 40 times positive 1 is still positive, so this whole thing is positive. If I put a negative 1 here, negative 1 plus 5 is positive 4. 4 to the 7th power is still positive. And if I put a positive 1 in here, I'm sorry, a negative 1 in there, negative 1 to the 2nd power is positive 1, plus 16 is 17. So this is also positive. So these are all positives, which makes this positive here. Which means we'd expect that between negative 5 and 0, at least, we should expect concave up. And then lastly, we'll try positive 1 inside of our second derivative to test in our number line. So I have 40 times 1 to the 8th times 1 plus 5 to the 7th times 1 squared plus 16. There's nothing negative anywhere near here, so this is all positives, right? This is positive, that's positive, that's positive. So the whole thing is positive. So we should also have concave up here between 0 and positive infinity. Okay. Now, things get a little tricky because there was no change of direction, as you can see, between this second region and this third region. So let's look at our answer choices. So the first choice says f of x is concave up between negative infinity and negative 5. Well, that's not true. We found that it was negative between negative infinity and negative 5. So we'd expect concave down. So that's out. F of x is concave up on negative 5 to 0. Yeah, we found that. I agree with that. And 0 to infinity. Okay, I agree with that as well. And concave down on negative infinity to negative 5. Yeah, so we actually found all of those things to be true. So I like this one. I'm going to read the other ones, but I do like this one. The third one, f of x is concave up on negative infinity to negative 5. Again, no, it's not. We found that it's concave down. So that's a no. This next answer says the exact same thing. That is concave up between negative infinity and negative 5. And the last one says f of x is concave up on negative 5 to 0, which I agree with, and concave down from negative infinity to negative 5, which I agree with. But then it says and 0 to infinity, which I don't agree with, right? We found that that was also concave up, not concave down. So that's gone. So the only answer that makes sense based upon the work we've done here is the second option. So again, as a review, we set the second derivative equal to 0. We find the solutions for x based upon that second derivative being equal to 0. We use those solutions for our number line test. We choose values within the range, right, like to the left and right of those critical points. And then we test those points by plugging them back into the second derivative. If what we get out is a positive, right, because we don't care about the actual number answer, just whether it's positive or negative. So if what we get is positive, it's concave up. If what we get is negative, then that region is concave down.